Hi guys, my name is Ronak and this is the second task provided by the Sparks Foundation, which is about predict the correct class for the iris plant using decision tree. These are some libraries I imported for the data analysis purpose. I have loaded the dataset, iris dataset using reads underscore CSV function from pandas library. For checking how many columns are present in our dataset, I have used df.columns, which gives us the whatever column present in our the dataset. Here id column, we don't need id column for the machine learning purpose, so I have just removed the id columns from the dataset. Now here species is available in the string or object data type. Our machine learning model does not understand the string or object data type, that it only understands numbers. So for converting it into the numbers, first I need to know how many categories are available in the species. So for that I will write this df.species.unique, that gives me the total number of unique categories available in that particular column species. So unique data available in the species column is iris setosa, iris versicolor and iris virginica. So now I need to convert it into the numbers. So I have decided to give iris setosa 0, iris versicolor 1, iris virginica 2, and using map function I have apply this to our data set. So wherever there is iris setosa, there will be a 0, and wherever there is iris virginica, there will be 2, or versicolor, there is 1. So for describing the dataset, for checking description of our dataset, I have used df.describe method to check the description. Now if there is null value present or not in dataset, I will check df.isNull.sum, which gives us there is no null values present in our dataset. Now I have plot the all the columns, so that gives me something like this. These are all well-shaped curve, so we don't need to scale our dataset. Now using box plot, I was checking that is there any outliers present here or not in our dataset. So in a sample width column, there are some upper outliers and lower outliers present in our dataset. So I have decided to remove that outliers from the dataset. For that I have used quantile method to remove this. I have removed upper 2% of dataset and lower 1% of dataset, which gives me something like this. After removing the dataset outlier, we can see that here that there are no outliers present in our dataset now. So now we need to move to our machine learning algorithm decision tree. For that we need to separate independent and dependent variable. Here independent variables are sepal length, sepal width, petal length and petal width, whereas dependent variable is species. We need to predict the species of the iris plant according to the these four independent features. So these are our X data, which is independent data set, and the shape of the X data is 143 by 4, means 143 rows are available in our data set. Now using train test split, I have splitted our dataset into the training dataset and testing dataset, where test size is 20% of the whole dataset. Here the X training dataset looks like this, which contains 114 rows and 4 columns. Now I imported the decision tree classifier. This is here we need to solve a classification problem, so we need to use decision tree classifier, and for showing the tree I have used export Graphviz. Here I have initialized the decision tree classifier model and train our model on training data X-train and Y-train, which gives score is 1.0, which is 100%. This is quite good, but our model is overfitted. If we check our model score on test data, which gives 93.10%. So here now I am checking how our tree looks like. So using export Graphviz, py.plus and ipython.display, I plotted the tree here using data. This is how our tree look like, decision tree look like. Okay, now we need to do hyperparameter tuning using grid search saving. For that I have imported this library, and I have give this much hyperparameters for the decision tree, and train our using grid search CV, I have trained our training data, and which grid search CV will give best parameters for our data set, which is something like this: criterion equal to Kini, max step 5, min samples lift 1, min samples split 2, and splitter is random. And the best score according to the grid search is 97.39%. So according to this, we need to pass these hyperparameters in our descent tree classifier model. After that, we need to train our model on training data, and then this this is the line in which I have predicted the y value on our x test data set, and checking the score, which is 100%. After hyperparameter tuning, we also get the score on test data is 100%. Now if after hyperparameter tuning, if I check how our tree looks like, so this is our tree looks like, which is smaller than the before the hyperparameter tuning. So in hyperparameter tuning, in hyperparameter tuning, this automatically removes the unnecessary branches, which increase the efficiency of the algorithm. So here I have saved the model and checking the output. So I have used the random data available, and this is according to the our conversion. This is versicolor, this is Satosa, and this is Virginica. Thank you.